The waters around Scotland's Isle of Arran have a range of protective measures. The Convex Seascape Survey team are here to find out if this protection is not only beneficial for marine life, but whether these measures also help to increase the amount of carbon that gets locked away in the seabed.
There are very few studies that have looked at the effects of protection on seabed carbon.
I think the data that we get will be vital.
The fieldwork is intense, with moments of elation and frustration. But this research will produce discoveries about how the ocean and climate are connected, knowledge which is needed now more than ever.
What we're doing is a first.
The study of blue carbon, or carbon stored in our oceans, is an emerging field. But with the oceans covering 71% of our planet, there is vastly more potential for carbon storage here than on land. And when we reach the sea floor, this difference is even greater.
I'm here with the Convex Seascape Survey from the University of Exeter to try and understand the ability of the seabed to capture carbon. We've been generating huge amounts of carbon emissions from the burning of fossil fuels over the course of centuries. We know how damaging and destructive that is, and we're seeking ways to get to net zero emissions. And part of that solution is to help increase the capacity of the ocean to absorb and store carbon.
Carbon is absorbed through the photosynthesis of marine plants, a large proportion of which are tiny microorganisms called phytoplankton. It is also dissolved into the water as carbon dioxide at the ocean's surface. Over geological time, a lot of that carbon eventually ends up at the bottom of the sea, locked away in the sediments.
If you come and churn it all up, you release that carbon back into the water. At that point, it can be chemically turned back into carbon dioxide. So in a way, it's re-emitted, and that re-emission could end up putting carbon dioxide back into the atmosphere.
As part of the Convex Seascape Survey, Blue Marine Foundation is working with the University of Exeter and Convex Insurance Group. In Arran, we've teamed up with the Community of Arran Seabed Trust, or COAST, to help facilitate the expedition.
I think it's really hard in regards to blue carbon because it's not something that you can view very easily. It is stored within the sediments, and some of the sediments aren't as glamorous or eye-catching as, a panda. Some of the best ones, what we're hoping to see is these mud habitats. You would look at them not knowing that these are amazing kind of areas of sequestration.
So the South Arran Marine Protected Area really provides what is a unique opportunity in the United Kingdom for us to be able to look at the effect of protection on seabed carbon stores. Because in the middle of the MPA, there is a place that is closed to bottom trawling and dredging, those two big activities stirring up the seabed. Then we've got a zone which allows trawling but not dredging, and then outside that, both activities are allowed. So there's a gradient of disturbance of the seabed from a lot to very little. And we're going to study how that shift in the community that lives there translates into the capture of carbon and its storage under the seafloor.
At the moment we're just unpacking all of our gear. We're heading out towards Holy Isle in the South Arran Marine Reserve. We've got 4 locations that we're going to look at, just loading up, and we're going to try out 4 different sampling techniques on the boat.
The scientists spend a month perfecting these techniques. If successful, these methods could be used internationally to study blue carbon. First up to deploy are the BRUVs. BRUVs are baited remote underwater video systems. With mounted cameras pointing at a can of bait, they attract and record marine life on the seafloor. The videos allow for many measurements to be taken, like species, size, and the number of animals seen. Bait is loaded, cameras set, and the boat positioned.
We lower them in as much as possible, but at the end it's a little bit of a drop.
Several more bruvs are deployed, and they will collect footage for the next few hours while the team operate the grab sampler. This takes a chunk of the surface layer of the seabed using retractable scoops. The sample is then sieved and washed, revealing the smaller creatures on the seafloor. The animal communities in this top 15 centimetres of the seabed play a role in how much carbon gets stored in the sediments. And they are especially vulnerable to disturbance from bottom-towed fishing gear.
We've just done 3 bruvs in that high protection zone, and we're going to do another 3 bruvs in this intermediate protection zone, and then we'll do another 3 outside where trawling, dredging, all those things are permitted. So we just really want to see if there is that clear impact on the fish communities, on the benthic communities, and but also on that carbon storage within the sediment across that gradient.
Next up, the ROV. This stands for Remotely Operated Vehicle. Essentially an underwater drone, this high-tech device can be driven into the depths and freely record videos of the sea floor.
So this is our actual ROV unit here. We've got 2 thrusters on the side, an internal 4K camera for filming the seafloor, and this swivels. Aim that down perpendicular, capture those screen grabs from the bottom.
But when the ROV reaches the bottom, the destruction is visible on the video. This is not a surprise, as this area has no protection from dredgers and trawlers, but it is a reminder to the team of why this work is so important. The consistent destruction of the sea floor has not only decimated most life, but it may well have released carbon too, something the vibrocore sampling will help to clarify. A vibrocore is a steel tube which vibrates at high frequency so that it penetrates the seafloor and collects the core of the seabed up to 1 metre in length. Our scientists will take these back to the lab to look at how much carbon there is in each sample.
Great. Yeah, so I mean, overall it's been a brilliant day, no complaints. We've proved concept for everything, so we've got 3 more weeks of this. Just got to crack on and start smashing it out.
We'll have to do some analysis in the lab back in the University of Exeter, so it's a period of months before the results will emerge. What we're trying to understand here is if protected areas can be our ally in the fight against climate change, and if they can, Arran will have taken the first steps, I think, on the path to slowing the rate of climate change by protecting the ocean.